Hello everyone. We're starting a free open lecture in our Discord channel. All our lectures are held daily without breaks. If you're a viewer and want to ask questions online and get answers, then join our lectures. You can find the link to Discord in our Telegram channel. To find out the time of the lecture, join our Telegram channel and Discord. Simple. XOR coloring. We have an undirected graph with n vertices from 1 to n. There are edges between the vertices if and only if their XOR is a prime number. XOR stands for bitwise exclusive OR. If you don't remember, XOR of 101011 equals 110. Why? Because if we have matching values, they give us 0. If we have different values, they give us 1. And if the XOR is a prime number, but in this case it isn't, it's 6. However, if it were 1, 0, 1, for example, then it would be a prime number. This means that there is a connection between vertex u and v. Connections exist only in this case. Color all the vertices of the graph using the minimum number of colors so that no pair of vertices directly connected by an edge is painted the same color. So we shouldn't end up with something like 101, which could give us something like 100 and 001. That means we have 4 ones connected. There's a path from 1 to 4. So we need to color the graph in such a way that 1 and 4 don't share the same color. It's clear that the color here is also represented by numbers, not words. So for example, they didn't have color 2, so we colored it with 2 and 2. We shouldn't have that. They should be different. Colors needed. For n, 2, 10, 5, n. Assume n for 2, 10, 5. Numbers it with 500. So let's take n as 2 to the power of 10 to the 5, because in each case we are really just given a number that is less than or equal to it, and we have 500 tests here. Again, this doesn't matter because it's guaranteed that they don't exceed that. Okay, so overall, in the graph, we can have 2 to the power of 10 to the 5 across all test cases. This is probably our worst case scenario. How many colors might we like here? Well, at least for a discount. Here, number theory is actually being used. This problem is right on it. Not 2? No, not 2. But that was close, but it's not 2, because how can it be 2 if the answer is at least 4? So the answer is 3, but that's actually a pretty close answer because we will need 4 colors. Why? Because actually 4 is a composite number, and that's enough. All the numbers before this, well, 1 is clearly not suitable, 2 is a prime number, and 3 is a prime number. What does that mean? What if we have a cycle? Well, if we just get the prime number 3, we had 1, 1, 0, 0, and there was some 0, 0, 1. And so they gave us the prime number 3, so they'll overlap with each other. Most likely, well, there's a probability, but if we have the number 4, then that won't happen. Why? Because if we had one number at 4, and then it went through some kind of cycle, essentially speaking, and ended up back at 4, it means that this prime number, the difference between them, is divisible by 4. And that means it's not a prime number because it's composite in essence. And that's it. Actually, this is everything that's here. It's the shortest and closest to a real explanation because you can go on for a long time and mathematically explain why it is this way, but it just is. And that's it. And what else? We're just going to output 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and that's because of this. The only case we need to specify is the case when we can use up to 4, and these are the cases that can be written out with simple if statements, or I made it a bit more complex. The whole task is a Dijkstra and diff1, well, plus diff2. So overall, it's probably somewhere around 1800, 2000, I don't know. Not sure.
Want to become a great programmer? Subscribe to our Telegram channel.